recording so I don't forget. Okay, going through the do now, we have segment AM is congruent to segment MB. And then we have circle O. Remember from the last class, anytime I tell you in the given information that we have a circle, somewhere in the proof, what is it that I want you to tell me? So anytime I give you a circle in the given information, somewhere in the proof, I need you to tell me something. Sion. No. Kyle. Good. Somewhere in the proof, I need you to tell me all radii of a circle are congruent. So we know in our head we're going to be using that somewhere in this proof. If we get through the proof and we haven't used that, probably something went wrong. Now, what is it that we want to prove? We want to prove angle AMO is congruent to angle BMO. Are angles and triangles the same thing? No, angles and triangles are completely different. Even though we use 3 letters for both of them, they're not the same thing. So when I say I want you to prove angle AMO, that's this angle, follow the letters, AMO, angle 1 right here. Congruent to angle BMO, that's angle 2 right here. So we need to get these 2 angles congruent. As of right now, there's absolutely no reason we are allowed to say angle 1 and angle 2 are congruent at this point in our proof. So also from the 2 classes ago and moving forward for the rest of the year, what did I say? When we're not able to prove what we want from the given information, what should we do? Vincent? Prove triangles congruent. Do we see 2 triangles here?
Yes.
Yes. What are the methods of proving triangles congruent? Somebody tell me one method. Simon.
Side, side, side.
Side, side, side is one way to prove triangles congruent. Sam, tell me another way. Side, angle, side. There's one more way. Michael. I'm sorry? Excellent. Angle, side, angle. These are the only ways to prove triangles congruent. So right now, I have AM and BM congruent. That's just one pair of sides. We'll go back to circle O. Does anybody see a pair of sides that are radii and sides of the triangle, that are both sides and radii? Alexios? You got it. AO and BO. So step number 1 is our given. It doesn't matter how you name the segments. Both are correct. So we're going to say AO is congruent to BO. Who knows the reason for this? Jerry. Good. Radii of a circle are congruent. Sion.
Is there a shorter way to say that?
I mean, that's pretty short.
It is short. Shorter.
No, we're good there. All right. So now we've gone through all of our given information. And what have I been telling you? Once we've exhausted our given information and we still don't have enough to prove triangles congruent, there's 2 things we could look for. Who remembers what those 2 things are? Antonio.
One of them was like a reflexive side, and then vertical angles.
Good. We either look for vertical angles or something reflexive. In this scenario, what do we have? Reflexive. We have reflexive. Do we all agree MO is the reflexive side here? Livy?
Is it okay if you say reflexive before?
Yes, absolutely. The order of the steps before you prove triangles congruent does not matter. So here we're going to say that MO is congruent to MO reflexive. So now I can go ahead and say triangle AMO is congruent to triangle BMO. What's the reason for this? John?
Side, side, side.
Side, side, side. All right, so now that the triangles are congruent, Now can I go ahead and prove angle AMO congruent to angle BMO? Adrian?
I forgot. How do you know what order to write the letters in for the triangle?
So the first triangle you write, it doesn't matter. So you could have named it any way you wanted, but for the second one, you have to match up the sides that match each other or the angles that match each other. So I decided first to go AMO, A to M to O. So we have 1 slash to the X to 2 slashes. So on the other side, I have to do the same thing. So 1 slash to the X to the 2 slashes.
So could you do it in a different way then? So if you wrote it OPM, would that work?
Exactly. So that's why I said the first way you name the first triangle doesn't matter as long as you match up the second triangle to it. All right, so now we can say angle AMO is congruent to angle BMO. Who knows the reason for this? That's it. Mia? CPCTC. Who knows what CPCTC stands for? Julia?
Corresponding parts of congruent triangles.
Excellent. Corresponding parts of congruent triangles are congruent. Will I ask you that question on the quiz? Yes. All right. So today I am going to fill your brains with so much information. We're going to be on a proof info overload. We're going to learn 2 new definitions. We're going to learn a postulate, and we're going to go beyond CPCTC today. So there's a lot going on in today's lesson. We're starting off with definitions. The first definition we're going to talk about is the definition of a median. Now, what a median does, it has to start at a vertex. When I say a vertex, so let's say I have triangle ABC. What do I mean when I say a vertex or vertices? What are vertices or a vertex? What is it? Cyan.
The F points, the angle, and the triangle.
Good. It's the angles in the triangle, right? So A is a vertex. It's the corners. The vertices are the corners. So A is a vertex. B is a vertex. C is a vertex. No matter what kind of triangle I give you, how many vertices will it have? 3. So what a median does, it has to start at a vertex. So it's going to pick a vertex. Let's say I start at vertex B. It's going to go to the opposite side, and it's going to split that opposite side into 2 equal parts. So what is a median very similar to? More than a midpoint, because a midpoint's just a point. So even more similar than just a midpoint. Maya?
Like a bisector.
A bisector. It's very similar to a bisector. Isn't that also a segment that splits it into 2 equal parts? Yeah. The difference is, does a bisector have to start at a vertex? No. Does a median have to start at a vertex? Yes.
Wait.
Yes.
Does that also mean the angles are bisectors as well?
Good question. The angles are not bisected, just the segment.
Only the segment. Okay.
Just the segment. Very good question. So you tell me what I'm drawing right now. Bisector or median?
Bisector.
Bisector. How do you know it's not a median?
It's not on the vertex.
It's not coming from a vertex. You got it.
Or at least a vertex from a triangle.
Good. All right, so I need us to draw in some tick marks that I forgot to draw in. So, oops, that's not what I want. So let's draw this in right here. And this here. All right, so looking at these 2 diagrams, can you just draw in the tick marks I drew in red? I should have put that in your diagrams initially. Okay. Before we start naming medians, since a median has to start at a vertex, how many medians does a triangle have? Since a median has to start at a vertex, how many medians? Good, 3. Every triangle has to have 3 medians. Does that mean all the medians are drawn in? No. Doesn't mean the medians are present in every problem, but they're there.
Wait, does that mean we can technically make our own?
We do not make our own medians, no. All right, So this is not important, but I'll fill it in anyway. All three medians intersect at a single point. This point is called a centroid, or the centroid. Right, like I said, not really important in your life, but I just put it in there anyway.
Is centroid important?
No.
Okay. On the test?
No.
Okay.
That's why I said it's not important in your life. Okay, so now let's go back up to 1 and 2. In number 1, can somebody name me the median? Can somebody identify the segment that's the median here? Vincent. You got it. The median here is segment AD. How do we know it's a median? It's starting at the vertex, it's going to the opposite side, splitting it into 2 equal parts. Number 2, can somebody name me, there's multiple medians here. Can somebody name me one median? Sam.
Oh, wait, sorry. Which one?
Number 2. What did you say? I didn't hear you.
Oh, sorry, I was on the wrong one. EH.
EH, good. EH is one median. Can somebody name me the other median? Oscar. FJ, you got it.
Wait, so medians only bisect segments, right?
Good. Medians only bisect segments. They do nothing to that top angle. They do nothing to that top angle. Yes. Nope, there's no order you have to list the letters. Any other questions on medians? All right, next definition, an altitude. So similar to a median, an altitude must start at a vertex, but its function is completely different. So a median splits the opposite segment into 2 congruent parts. An altitude makes right angles with the opposite segment. So an altitude, similar to a median, has to start at a vertex, but then goes to the opposite side and makes right angles. It does not split it into 2 equal parts. It does not split the segment into 2 equal segments. It just makes right angles.
Wait.
So an altitude is very similar to what? An altitude is very similar to what? Not similar to a median because they have different functions. The only thing similar about them is that they start at the vertex. Maya? Perpendicular lines. An altitude is very similar to perpendicular. All right, what's the difference? Does perpendicular have to start at a vertex?
No.
Does an altitude have to start at a vertex?
Yes.
Yes. So tell me what I'm about to draw right now. Perpendicular or altitude?
Perpendicular.
Perpendicular. These lines are perpendicular. How do we know it's not an altitude? Because it's not originating from a vertex, yeah. All right, let's draw in these right angles for me, please. I should have put these in your diagrams initially, but I didn't.
What's that little dotted line?
So when we get there, I'll explain it. It is a dotted line. It's showing that it's not part of the triangle, that it's falling outside of the triangle.
It's like a helping line.
It's a helping line, exactly. It's not really part of the triangle.
Why'd you put a box on neutral H?
We're going to talk about it.
How can you tell the difference between a median, visually?
Either they make right angles or they make congruent segments.
Label it for me.
It will always be labeled. This was my mistake that I didn't label it for you. Okay, so let's look at, well, first let's start off with, since an altitude has to start at a vertex, how many altitudes does a median have? Does a triangle have? How many altitudes does a triangle have? 3, one from each vertex, right? Now, everyone look at number 5. If you have an obtuse triangle, an altitude a lot of times identifies the height of the triangle. So right now we have this obtuse triangle. Your altitude is allowed to fall outside of the triangle. That's perfectly okay. So the height of the triangle, if it's positioned this way, wouldn't it be to that highest point M? But it wouldn't be MN because that's slanted. When you find the height, it has to be nice and tall and straight, making right angles. So altitudes are absolutely allowed to fall outside of the triangle. That's okay.
But everything else is not okay.
Like medians will all be inside the triangle, correct?
Okay. And then, okay.
So number 3, can somebody identify the segments that are altitudes here? Which segments are altitudes? Kyle.
Segment DA.
Good. Segment DA is an altitude. What's another altitude? Simon. BE is another altitude. All right, number 4. This was a little tricky. Number 4, tell me one altitude that you see. One altitude that we see, yeah. Sam. HJ. There are actually 2 more altitudes. There are actually 2 more altitudes in number 4. 2 more altitudes. Jerry? HK, perfect. One more altitude. Kyle? HG. Why are these altitudes? Isn't G a vertex? Isn't it going to the other side and making a right angle? That's an altitude. Isn't K a vertex? Isn't it going to the other side and making a right angle? That's an altitude. So an altitude can actually be sides of the triangle. That's okay. So an altitude could fall inside the triangle. It can fall outside the triangle. It could actually be sides of the triangle. That's all okay. I'm sorry?
A median.
Nope, a median all cuts through the triangle, starts at a vertex, cuts through, goes to the other side. It's not a median. These are altitudes.
Oh, God. So the reason that 4 is an altitude is because
KH is an altitude because K is an vertex. It goes to the opposite side and makes a right angle. GH is an altitude because it starts at G, goes to the opposite side, makes a right angle. So sides of a triangle are allowed to be altitudes as well. So every triangle has how many altitudes? 3. All right, let's scroll down to where it says postulate. I'm going to tell you a postulate that you have to memorize verbatim. I will not take any variation of this wording. You have to memorize it exactly. So the postulate reads, 2 points determine a segment. You must memorize this verbatim. A lot of students like to say 2 points make a segment. 2 points don't physically make a segment. They can't. They're points. Right? So it's 2 points determine a segment. What this means is anytime I have 2 points, we can create a segment by drawing a segment connecting those 2 points. That is allowed. That's what it means when it says 2 points determine a segment. That it only takes 2 points to create a segment. It only takes 2 points to create a line. That's what that means, 2 points determine a segment. That as long as you have 2 points, you can always create a segment between them. We're going to use this a little bit later on in the lesson. All right. So we went through our definitions. We went through our new postulate. Now we're going to go beyond CPCTC, which means the proof is not ending at CPCTC. We're adding more steps. Process is still the same though. Go through, mark up your diagram with your given information, and make conclusions if possible. So here it says that segment AC is congruent to segment BC. No conclusion to make there. Livy, you with me?
Yeah.
Adrian?
Wait, so you can make conclusions in any order, right?
Yep, correct. Then we have segment AD is congruent to segment BD. No conclusion to make there. All right, let's look now at what we want to prove. We would like to prove that CD bisects angle ACB. If you bisect an angle, if an angle is bisected, what results from that bisector? Somebody knew, somebody knew. When you bisect an angle, what do you get? John, is your hand up or no? No. When you, none of these hands are new. Max. Two congruent angles. So if we're going to prove that CD bisects angle ACB, go to the middle letter. What's our middle letter?
C.
C. Look inside. Do you see two angles inside by C?
Yes.
Those are what we need. I'm going to call them 1 and 2. In order to prove that CD bisects angle ACB, we need to show that 1 and 2 are congruent to each other. As of right now, do we have enough to say 1 and 2 are congruent to each other? No, we don't have enough to say 1 and 2 are congruent to each other. So what's the plan? When we can't prove what we want from the given information, what is the plan? Alexios. To prove triangles congruent. Right now, I have 2 sides already. Is that sufficient? No, we need something else. Mia.
That CD is
Good. CD congruent to CD reflexive. So step number 2, I'm going to say that CD is congruent to CD reflexive. Do I now have enough to say the triangles are congruent, Max?
Yeah.
Yeah, by what method, Max?
Side.
Excellent.
Also,
Yeah.
so if you don't find a vertical angle, is it always going to end up being reflexive?
It's either going to be vertical angle or reflexive. That's assuming that we didn't have enough from the given. Yep, exactly. So I'm going to say triangle ACD. And now I said triangle ACD. Adrian, what are you going to say?
CBD.
So that if you said CBD, that means C and A match up together. Is that right? So I went from A to C to D. Now do the same thing on the other triangle. BCD.
Wait. Could you use reflexive property on entire triangles?
No, reflexive only applies to segments and angles. That's it.
Okay.
So now we have triangle ACD is congruent to triangle BCD, and that was SSS, side. Can I now go and say CD bisects angle ACB? How many people say yes? How many people say no? Why not? Why can't I say this? Oscar? Because we haven't proved the angles congruent. In order for CD to bisect ACB, we needed 1 and 2 to be congruent. We don't have those congruent yet. Can we now say that 1 and 2 are congruent?
Yes.
Yeah, Sophia, why?
the triangle angles of ACB and BCD congruent, so that means the angle is congruent too.
Exactly. Because the triangles are congruent, those angles have to be congruent. Do you remember the reason in the proof for that? A bunch of letters together. You got it. CPCTC. Excellent. So now we got angle 1 congruent to angle 2. Now that we've been able to successfully say 1 and 2 are congruent, can we now prove that CD has bisected angle ACB? Yes. So step number 5. CD bisects angle ACB. Who thinks they know the reason for this? Sion? Yep, def of bisect, you got it. Okay. In the realm of difficult problems, do you think this, in my opinion, would be classified as easy medium, or hard?
Es
Easy.
muy fácil.
How many people think this would be, I would consider this an easier problem?
It is definitely.
How many people would think of this as mid-level? Difficult. Okay, in my opinion, I would classify this as an easier problem because everything was pretty straightforward. I didn't really throw any tricks at you, right? It was all pretty straightforward. All right, let's go to number 3. Let's step it up a little bit now. We're going to learn something new also.
Wait, if you like label like an angle in a problem like yourself, like these are the 1 and 2, you could reference it in like your proof.
Always. Yep. Okay, go through the given, make a conclusion. G is the midpoint of FH. Raise your hand, tell me what is this conclusion I'm going to get if G is the midpoint of FH. Boy, same hands every time. Daniela, if G is the midpoint of FH, what can I conclude there?
HG is congruent to GF.
You got it. HG is congruent to GF. And Daniela, what's the reason for that?
Depth of midpoint.
You got it. Depth of midpoint.
Do we have to make our own line for this?
I like where you're going with this, Simon. All right. So right now, oh, sorry, there's more given. What's the next given? EH congruent to EF. We want to prove angle 1 congruent to angle 2. I'm going to highlight them. Angle 1 congruent to angle 2. That's what we want to prove. As of right now, we're not able to prove that. What do I always say? When you cannot prove what you want right away, prove triangles congruent. What's the problem with that process here?
There's only one triangle.
There's only one triangle. So now when you're in a situation like this, when there's only one triangle, when you're in a situation like this where there's only one triangle, this is where you create your 2 triangles by drawing a line. The 2 points have to already exist in the diagram. You cannot create your own points. But do you see point E and do you see point G?
Yes.
Can I draw a line connecting E and G?
Yes.
Absolutely, because it only takes 2 points to determine a segment. So I'm going to go ahead, and usually we draw it with a dashed line. All right, and ready for the new step in your proof? So you're going to say, as your statement, draw, and then you segment EG, segment EG. So you're going to say draw segment EG. And your reason to match this is going to be 2 points. Determine a segment. Yep, it's the postulate. I'm going to highlight this. This was our new step that we've never done anything like this before.
Wait. Oh wait, I see how we can prove the 2 triangles congruent now.
Good. So there's our new. Okay, there's our new step that we've never done before. Okay, so now we have 2 triangles. Do you agree? But do 1 and 2, are they inside of these triangles? They're not inside of these triangles. So is this going to be a simple CPCTC problem?
No.
No. But look at where I'm going with this. On the inside of the triangle, I'm going to put an angle 3 here. And on the inside, I'm going to put an angle 4 here. Are 3 and 4 inside the triangles? Yeah, Vincent, where am I going with this?
You state that angle 1 is supplementary to angle 3 and angle 2 is supplementary to angle 4.
Eventually, we're going to work with subs. But before we can do that whole sub process, what do I have to do first before I can do the whole sub process? Jerry? Prove the triangle's congruent so we can do what? Before I can do the sub process. Antonia?
So that you can say that angles are congruent.
Because I first need 3 and 4 congruent, because isn't the theorem supplements of congruent angles are congruent? But 3 and 4 right now are incongruent, so that wouldn't help me get 1 and 2 congruent. So I need to prove the triangle's congruent so I could then get 3 and 4, so I could then get 1 and 2. Do we see this layered process that's going on now? All right, so let's get these triangles congruent. I have 2 sides. What next? I have 2 sides. What do I need? Jen? You got it. EG congruent to EG reflexive. Now I can say triangle EGH. Adrian, I said triangle EGH. What are you going to say? You got it. And what's that going to be that reason, Max? What's the reason for this? Excellent. Side, side, side. What should I do now? What should I do now? Giselle, what should I do now?
So angle 3 is congruent to angle 4 because of CPCTC.
Excellent. Angle 3 is congruent to angle 4 because of CPCTC. So what am I doing now? So we just got 3 and 4 congruent. So our end goal is 1 and 2. Our end goal is to get 1 and 2 congruent. We're going to use 3 and 4 to help us get 1 and 2. So you got it. Angle 3 is a supplement to angle 1, and angle 4 is a supplement to angle 2. What is the reason for this, Soph? You got it. Perfect. Def of sup. Not for this reason, because think of what you're saying if that were the reason. Supplements of congruent angles are congruent. That means your statement would be stating congruent angles. We're not stating congruent angles. We're just saying these 2 angles add to make a straight angle. That's all that's saying. Adrian?
Do you have to state that as a straight angle?
No more. We no longer have to do that. Cyan?
Are there 7 or 8 steps?
There's
7 steps.
Oh, did I miss number?
I think
1, 2, 3, 4, 5, 6, 7.
No,
No,
there's
there's 8 steps.
There's gonna be 8 because it's
We're not done yet.
this is how we had it.
You have to write it.
All right, so what is the last thing we're proving, Max?
Angle 1 is congruent to angle 2 because subs of congruent angles.
Excellent. Subs of congruent angles are congruent. Yes, Oscar.
Does it matter which one, what angle we say is supplement to which angle?
Does not
So,
matter.
like, angle 1 supplements angle 3.
Yeah, absolutely, that's fine.
Oh, so that's where you put it. You put that for something.
All right, we are going to skip number 4. We're going to skip number 4. Let's go on to number 5. So my opinion, this is like medium hard. It's like not the hardest problem I could give you, but it's definitely like closer to hard. It was just a lot of steps, a lot to think of. All right, number 5. Number 5. Let's do this. We're going to use our new definitions in this one. So go through our given, make conclusions. So angle CFD, that's this angle, I'm going to call it angle 1, is congruent to angle EFD, which I'm going to call angle 2. And then it says FD is an altitude. Think back. I know I've just cluttered your brain with so much information. Think back to the beginning of the lesson. What does an altitude make? Michael.
Right angles.
Right angles. Okay. Michael, you have a lot of voices today. All right. It makes right angles. Where are we making the right angles? Oscar.
By angle
by angle D. Can I call them 3 and 4?
Yeah.
Yeah. All right, so we have to now declare this in our proof. So step number 2, I'm going to say angle 3 and angle 4 are right angles. Who thinks they know the reason? Who has a guess on the reason? Michael. Def of altitude. I shortcut it ALT. All right, I'll give you all a second to catch up. Bless you.
I don't think we're gonna have space for the last question if we're gonna do it.
All right, so now what I want us to do is to get in the habit, the minute you declare right angles, I need you then to say those right angles are congruent. Whether we're gonna use it or not, I want you to get in that habit so you don't miss the step. Whether we're gonna use it or not, I need you to get in that habit so you don't miss that step. So I declared right angles. That doesn't mean that they're congruent. That just means I have 2 right angles. Now I'm gonna go ahead and say 3 and 4 are congruent. Angle 3 is congruent to angle 4, and the reason is, oh, this is not a definition. This is not def of right angle. The definition of a right angle is that it's 90 degrees. Livy.
All right angles are congruent.
You got it. Right angles are congruent. Because remember, like angle, side angle, or side angle, side means we have to have congruent angles. So we just said that they were right, but we didn't tell the reader that they were congruent yet. All right, so now I have 2 angles. I have 2 angles. Let's look at what we want to prove. We want to prove that FD is a median. Well, if FD is a median, what would we have to show if we're showing that it's a median? What ultimately would we have to show? Excellent. We need to show CD and DE are congruent. Do we have that right now? No. So what am I going to go to prove? The triangles. I have AA. AA is not enough. Julia? You got it. FD congruent to FD reflexive. Then I could go on and say triangle CDF is congruent to triangle EDF, angle, side angle, ASA. What's my next step? Oh, bell's gonna ring. Next step is gonna be that CD is congruent to DE, CPCTC. And then last step is FD is a median Y. Sion? Def of median. You got it. Def of median. All right. We don't have time to do the last problem, but you guys are still good with all your knowledge. All right. We're good to go. Don't forget your phones. Yes, you do have homework. It's listed here. I'll post it on Classroom.